matrix A, which is 3, 1, 4, 1, 5, 9, 4, 9, 2. The first subscription, we need to find the transpose of matrix A. So the transpose of a matrix is found by interchanging a row into columns or columns into row. So the transpose of the matrix is denoted by using the letter T in the subscript of the given matrix. For example, in these cases, the given matrix is A, then the transpose of the A matrix is represented by A subscript T. To find the transpose of matrix A, the element in the first row of matrix A, which is 3, 1, 4, are written in the first column of the transpose matrix. Similarly to the second and third row. So we get the answer A transpose is equal to 314,159,492. For the second subscription, we need to determine whether the matrix A is symmetric or not. So just looking at the transpose matrix, it has the same element on both column and rows. Hence, we can see this matrix A is symmetric as this matrix is transpose is equal to the matrix itself. For the next question is to find the inverse of a matrix. So given C, 2, 1, 0, 1, 3, 1, 0, 1, 2. So first one, we need to compute the determinant. To find the determinant, we use matrix expansion method. For this method, first we need to write the first, second and third column of the matrix C as usual. Then we write again the first and second column only next to the matrix. As we doesn't want to get confused, we make the line boundary as you can see. So what are we going to do is we are going to multiply the number in diagonal starting from the top left going to the bottom right that was highlighted by purple color. So you can see 2 times 3 times 2. Then we plus 1 times 1 times 0 and plus another diagonal purple highlighted things 0 times 1 times 1. Then this number we subtract with the product that we get when we multiply the diagonal direction in the blue highlighted, which is 0 times 3 times 0 minus 2 times 1 times 1 minus 1 times 1 times 2. Then after that we got the product, which is 12 plus 0 minus 0 minus 2 minus 2, and we get the determinant of matrix C is equal to 8. So to find the inverse of this matrix, we write the formula how to find the matrix C first. So you can see matrix inverse C is equal to 1 over determinant C times adjoint C. So adjoint C is the cofactor matrix that are transpose. So in these cases, we use cofactor expansion. So at the first place, we write the box with the sign at the position, at the elements of position. As you can see, the first element already positive, then negative, positive, negative, positive, negative, positive, negative, positive. So next, we need to calculate the cofactor matrix for this element. So the cofactor matrix is found by calculating the determinant of the 2 times 2 minor matrices with alternating sign that we are writing just now. So what is minor determinant? So for each element C, we already highlight the row and column of that element that we need to multiply to get the element for cofactor matrix. Okay, so you can see 3 times 2 minus 1 times 1. So we get the first element of cofactor matrix is equal to 5. So as the second one, 1 times 2 in the highlighted red, then minus 1 multiplied by 0. So we get 2, but because of this position have the negative sign, so we need to add the negative sign. So same goes as another element. Then after we get the cofactor matrix is equal to 5, negative 2, 1, negative 2, 4, negative 2, 1, negative 2, 5. Then how to find adjoint C? So we just need to transpose the cofactor matrix and get the adjoint C. But if you can see, this is the same actually. Doesn't change. The element doesn't change at all. So yeah, that's all. So after find the determinant and get the adjoint C, we can already find the inverse of matrix C. So we just put the value that we get into our formula that we have written before. So 1 over determinant C, which is 8, times adjoint C, 5, negative 2, 1, negative 2, 4, negative 2, 1, negative 2, 5. So we just times it and we get inverse of matrix C is equal to 5 over 8, negative 1 over 4, 1 over 8, negative 1 over 4, 1 over 2, negative 1 over 4, 1 over 8, negative 1 over 4, and 5 over 8. That's all. For the next question, we need to find the inverse of matrix using adjugate matrix. So adjugate matrix actually same as adjoint matrix as I have mentioned before. So this given matrix G, which is 2, 1, 0, 1, 2, 1, 0, 1, 3. Firstly, we need to find the cofactor matrix of G. Same as before. 2, we use cofactor expansion. So firstly, we need to write the sign based on the element's position first. So how actually we want to find the cofactor of matrix? So given matrix G, okay, as the first element is at first row and first column, so we use our fingers or maybe pen, we close it. We close the first row, which is 2, 1, 0 at the matrix G, and 2, 1, 0 at the first column. Then we get the new minor matrix, which is 2, 1, 1, 3. 2 times 2 matrices at inside the 3 times 3 matrix. So this is how to find the cofactor matrix. Then we just times 2 times 3 minus 1 times 1. Then we get the first element is 5. Then for the second element is same. We close the first row and the second column. Yeah. So we close, we get 1, 1, 0, 3. So 1 times 3 minus 1 times 0, we get 3. Don't forget the sign is negative. So we get the cofactor matrix of G is equal to 5, negative 3, 1, negative 3, 6, negative 2, 1, negative 2, 3. So for the next thing, we find the determinant of matrix G. As before too, we use matrix expansion method. Okay, so as you can see, we just need to write the matrix of G and we add the first and second column from the matrix G2. Then we just multiply the purple highlighted direction. So and we minus these products with the blue highlighted product. We can see 2 times 2 times 3 plus the second highlighted purple, 1 times 1 times 0 plus 0 times 1 times 1. Then we minus blue direction, highlighted direction, minus 0 times 2 times 0, minus 1 times 1 times 2, minus 3 times 1 times 1. Then we get the determinant of matrix G is 7. For the next equation, we need to find the adjoint, or in this equation it mentioned adjugate matrix, so it's still the same. So adjugate matrix is we need to transpose the cofactor matrix that we already get at the first place. So we transpose it, we get 5, negative 3, 1, negative 3, 6, negative 2, 1, negative 2, 3. Then to find the inverse of matrix G, 1 over determinant G times adjoint G is equal to 1 over 7 times the adjoint G. We get inverse of matrix G is equal to 5 over 7, negative 3 over 7, 1 over 7, negative 3 over 7, 6 over 7, negative 2 over 7, 1 over 7, negative 2 over 7, and 3 over 7. That's all.